Hi everyone. Today we'll be discussing the LeetCode problem of the day. Find x sum of all k long subarrays part 2. So here you are given an array nums of n integers and two integers k and x. So the x sum of an array is calculated by the following procedure. So first in the array you have to count the occurrences of all the elements of the array. And in that occurrences you just have to keep the top x most frequent elements. And while doing this, if two elements have the same frequency, then the element with the biggest value will be considered to be the most frequent one. Then you have to calculate the sum of the resulting array. So note that if the array has less than x distinct elements, then its x sum is equal to the sum of the whole array. Let's quickly take an example. We have the array like this: 1, 2, 2, 3, 3, and 3. And suppose we are given the value of x equal to 2. So in this, 3 has a frequency 3, and then 2 has a frequency 2. Okay, let's make it more. Yeah, 2 has a frequency 4, and 1 has a frequency of 1. So we have 3 elements. In that, we have to pick the first top x most frequent elements. So we have to consider only these elements and remove the rest. So your array will become this, consisting only these elements, and your x sum is the sum of all these values, which is 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3. So it is 8 plus 9, 17. So this is the x sum of this array. And suppose in this example only, if your x was 4, in this case you only have 3 distinct elements. So the x sum will be the sum of the entire array. So in this question, he is asking you to return an integer answer of length n minus k minus 1, where answer of I is the x sum of the subarray from I to I plus k minus 1. So let's look at this with an example. So first we have the array 1, 1, 2, 2, 3, 4, 2, 3. So this is the array, and you are given the values k equal to 6 and x equal to 2. So you have to return an array answer of length n minus k minus 1. So that means first you have to calculate the x sum for the first subarray of size equal to k. So this is the first subarray. Then you have to calculate the answer for this subarray. And finally, you need to calculate the answer for this subarray. So totally you have 3 subarrays, which means n minus k plus 1. Here n is 1, 2, 3, 4, 5, 6, 7. N is 8. So 8 minus 6 plus 1, which is total 3. So you'll have your answer will be of size 3, and it will store the x sum of all these 3 subarrays. So let's just see how the x sum is calculated for each of the subarray. So in the first subarray, we have the elements like this. So 1 has a frequency 2, 2 has a frequency 2, 3 has a frequency 1, and 4 has a frequency 1. So in this, we have x equal to 2. So we have to pick the top 2 most frequent elements. So these 2 are the top 2 most frequent elements. So the array will contain only these elements. And when you add it, so 1 is present 2 times. So 2 plus 2 is present 2 times. So 4. So the x sum will be 6, which is equal to 1 plus 1 plus 2 plus 2. So in your output, the first index is 6. Now let's look at the second subarray. The next subarray will start from this point and end till here. In this subarray, the 1 is present 1 time, and 2 is present 3 times, and 3 is present once, 4 is present once. Now out of these, we have to pick again top two most frequent elements. So the first one is obviously this. Now in the second one, we have three elements which are tie. So all the elements have frequency 1. So in the question, he mentioned that if two elements have the same occurrence, same frequency, the element with the biggest value is considered. So in this case, 4 is the biggest value, so 4 is considered. So these two are the most frequent elements, and their sum is 2 is present 3 times, so total 6, plus 4 is present 1 time, so 4. So total we have 10. So for the second subarray, the answer is 10. Now finally, let's see for the last subarray. 2, 4. So the last subarray starts here and it goes till the end of the array. And frequency of 1 this time is 0. Frequency of 2 is 1, 2, 3. Frequency of 3 is 2. And frequency of 4 is 1. For the last subarray, these are the frequencies. And in this, clearly we can see these two are the two most frequent elements. So 2 is present 3 times, so it will contribute 6 to the sum. And 3 is present 2 times, so this will also contribute 6 to the sum. So total answer will be 12. So for the last subarray, the answer is 12. Fine. Let's look at the second example also quickly. So we have P8, 7, 8, 7, 5. So for the first subarray, here we have k equal to 2, x equal to 2. So for the first subarray, the answer will be 8 plus 3, which is 11. For the second subarray, like these two are the two most frequent elements, so answer will be 8 plus 7, 15. For the third subarray, 7 plus 8, again 15. For the fourth subarray, 8 plus 7, again 15. And for the last subarray, it is 7 plus 5, 12. So this is the output for the second input. And we have the constraints. The array size can be up to 10 power 5, and each element in the array can be up to 10 power 9. So that's the reason why he has taken long to prevent the overflow. Now let's go over the approach. So let's discuss the approach through this example. We have 1, 1, 2, 2, 3, 4, 2, 3. So out of this array, you have the subarray size equal to 6. So first you will start with the first subarray, starting at index 0 and taking the first 6 elements. And for this, if you just need to find the answer, you will simply first segregate all the elements, like based on the frequencies. Like suppose 1 has a frequency 2, 2 has a frequency 2, and 3 has a frequency 1, and 4 has a frequency 1. So we have all these four your numbers which has some frequencies associated, and if you sort these numbers based on the rule which he has given, rule in the sense the numbers with the most frequency will appear first, and if there's a tie, then the number with the greatest value will appear at the starting. So that means if we somehow store all these keys in a data structure, which using the custom comparator, which will sort them based on this, based on the priority we are defining. So in that case, out of these 4 elements, first we'll have 2, because 2 has a frequency, the greatest frequency. Then after that we'll have a 1, then we'll have a 4, then we'll have a 3. So 4 and 3 both has a frequency, both have the same frequency, but if the frequency is same, we have to then compare the elements. So 4 is greater than 3, so 4 is appearing first. Now, once we have this, all we need to do is, since in this example x equal to 2, we just need to pick the first 2 elements from this data structure. And those two elements will be our answer. So the first element is 2, and this is a hash map. So from this hash map, we can see what is the frequency of 2. The frequency of 2 is 2. So total 2 is present 2 times. So its contribution is 4. And the next element is 1. And 1 is also present 2 times. So its contribution is also 2. So total answer for the first subarray will be 6. Now, similarly, we can do the same, we can repeat the same process for the second subarray also. But if we do that, we would again like build this set this data structure, and on the data structure we'll again pick the top X elements, and that will cause us additional time, because for processing this subarray you will again need to process all these elements and add it to your answer. So instead of that, we can use a sliding window technique. So let's see how we can do that. So first thing is you will get the answer for the first subarray, which is 6. So let us store this 6 answer somewhere. Answer equal to 6. And also here we can see that initially we have added all these elements in our data structure, but while finding the answer for the first subarray, we picked only the first 2 elements. So when we pick the first 2 elements, we will add them to another data structure, another similar data structure. So when you process the first subarray, these two will get added in this set. 4, 3. So the data structure we'll be using here is a tree set. We just write it. So we can create a tree set because we can, at any point, we can check whether a given key is present in the tree set, or if we have a key, we can go and delete the key in this. And in the tree set, we can also use a custom comparator to sort the keys according to the logic we have here. If the frequencies, we have to sort them based on the frequency, and if frequency is equal, we have to sort them based on the bigger value. So we have two sets. The first set is, let's say, the top set, which will actively contain the top X elements. So in this window, we can see that 2 and 1 are the top 2 elements with which are most frequent. And let's say this is the bottom. And also we'll maintain a hash map to store the frequencies of each element. So now, once the first window is done, we'll move to the second window. So this is our second window. In our second window, there are 2 things happening. So the first thing is a new element is getting added, which is 2, and one element it's getting removed from our previous window. So what we can do is, the first thing, we are adding a 2. So we'll check in our top tree set. If we have a 2, we'll first remove it from our hash set. So we'll delete the 2. And since you're deleting the 2, you'll also subtract the 2's contribution in your answer. So initially your sum was 6. Let's take this sum. So initially your sum is 6. So from your 6, you will subtract this 2's contribution. 2's contribution is 2 into 2 because it's present 2 times. So sum will be 6 minus 4, which is 2. So you're entirely removing this 2 from your tree set, so wherever it is present. And next, you are removing this 1 from your window. So the same thing, you'll again check where your 1 is present. So 1 is present here. So you'll remove this from your set. And since it is from the active, it is from the top set, you will also remove the sum. So now 1's contribution is 2, so sum will be 0. Note that while removing the elements, suppose here instead of 2, we had a 4. So 4 is present in the bottom set. So when you delete the 4, you won't update the sum. You'll only update the sum when you delete the elements from your top tree set, because this is the set where from which you are getting your sum. So now what happened is we have a 2 which is getting added. So first thing, we have removed 2 from our set, and next you have a 1 which is getting removed from your from your window. So the 1 also we have removed. So currently the top tree set is empty. So once you do this, you need to update your frequency in your frequency table. So 2 is getting added, so its frequency will increase by 1. It will become a 3. And 1 is getting removed, so its frequency will decrease by 1. So the frequency will be 1. Now we are adding a 2 to our tree set. So first we'll add all the elements to our bottom tree set, and from that bottom tree set we will transfer the elements to our top tree set until we have at least X elements in them. So here we will add 2 to this bottom set. So when you add this 2, 2 has the frequency 3, so 2 gets added at the starting. And the same thing again, you will add the 1 as well. So 1 has a frequency 1. So when you add this 1, the 1 will appear at the last, because all the frequencies are same. So when the frequencies are same, you will check the element. Since 1 is the smallest among all these, so 1 will be added at the bottom. So after adding, this will be your final preset. And once you do this, you'll again repeat the process. You will transfer elements from here to here until you find the top X elements. So what you do is, first the top element is 2. So you'll transfer 2 from here to here. And since whenever a new element is added to this top tree set, you also need to update the sum. So 2 is getting added, and 2's frequency is 3 from the hash set, from the hash map. So in your sum, you'll add a 6. Now 2 is added. The next element is 4. So you also will add a 4. So 4 is also added, and 4's frequency is 1. So you'll just add a plus 4. So your total sum will be 10. So you can see that you'll repeat this process until the size of this asset is reaching 2, or this bottom is empty. So since the size is equal to 2, you'll stop the process. And once the process is done, you can see for the blue window, 2 and 4 are the top 2 most frequent elements, and their sum is 10. So you can see 10 is the answer for this. Now let's look at the next window. I think this will make it a bit more clear. So let me add the next window. So in the next window, again, we have 2 things happening. First thing is a 3 is getting added and 1 is getting removed. So first you'll check where 3 is. So 3 is present in the bottom tree set. So you'll simply delete the 3. And since 3 is deleted from the bottom tree set, you won't update the sum. So first 3 is deleted, and also 1. So 1 is also deleted. You will delete both 1 and 3. So after doing this, you will update your frequency. So 3 is getting added, so its frequency will increase by 1. So you will have 2 here. And 1 is getting removed, so its frequency will decrease by 1. So 1's frequency is 0. So whenever you have an element whose frequency is reaching 0, you can simply remove that element directly from your hash map. So we'll just remove this entry. So after updating the map, you'll again add back the 3 and the 1 to your bottom tree set. So you'll add the 3 in this, and you'll also try to add 1. But when you try to add 1, you will first check if if it's present in the hash map. Since it's not present in the hash map, no need to add this one. So after adding 3, this is your final 2 tree sets. And after adding this, you will first try to transfer this to this until the top tree set has at least X elements. So this top has already 2 elements, so transfer doesn't happen. And after the transfer, you'll also check whether the topmost element in this bottom tree set has a greater priority than the bottommost element in the top tree set. So we'll just compare the top element and the bottom element of these two tree sets. So let's see. The topmost element in the bottom is 3, and this has a frequency of 2. And the bottommost element in the top tree set is a 4, and it has a frequency 1. So here we can clearly see that this 3 should be given more priority because 3 has a greater frequency. So we notice that this element should have been here and 4 should come here. So we'll just swap these both. So the first thing is you will remove the 4 from the top, and when you remove the 4, you'll also remove the contribution of it. So previously your sum was 10. So from the 10 you will subtract 4. Sum will be 6. So 4 is removed. You'll add the 4 in your bottom tree set, and you'll delete 3 from here and add your 3 in this top tree set. And since you're adding a element to your top tree set, you'll also update the sum. And the 3's contribution is 2 because the frequency of 3 is 2. So total you'll add a 6 and your sum will be equal to 12. So 12 indicates the X sum for the third subarray. So the logic is pretty simple. Whenever you have you are going to a new window, there are 2 elements. One element which is getting added and another element which is getting subtracted. So the first thing you'll do is you'll delete both of these numbers from this tree set, so wherever they might be present. And once that is done, you'll update your hash map with the updated frequency. So that again you'll add back both these elements, but you'll add them in your bottom tree set. And from your bottom tree set, first you'll try to transfer all the elements to your top tree set until the size of this is equal to X. And once that is done, you'll also compare whether the topmost element in the bottom tree set has a greater priority than the bottommost element in this tree set. The reason why this can happen is, so we can see here that for this subarray, 2 and 3 are the topmost frequent elements, and after that, just after that, we have a 4. So let's say in the next few iterations, 4 is getting added, and let's say 3 is getting subtracted. So if a 4 is getting added, so 4's frequency will increase by 1, and 3's frequency will decrease by 1. So in this case, we can see that the element present in this top is getting a reduction in its frequency, and element present in the bottom tree set is getting a increment in its frequency. So when this happens, there's a high chance that this element might be given greater priority than element present in the top tree set. So that's why we just compare the bottommost element in this one and the topmost element in this one. If this has a more priority than the bottommost element in this, we just swap it. And when we swap it, we'll also update our sum according to the swap. Now let's code the approach. So I'll be dry running the code with the same example. So first let's array size and also create answer array. its size will be n minus k plus 1, and a variable which will actively store the sum of each subarray. And let's create a hash map. And after this, we also need to create two tree sets. So one tree set, it will contain integer. Let the first tree set be top x set. And the next one is bottom set. Also, for the tree set, we need to define the custom comparator, like how the keys will be sorted. So for that, we can just add new comparator. So while comparing, we will have two integers, integer A, integer B. So first, we'll compare based on the frequency of these integers. So let's first get the frequency. Frequency A is map.get. So here we are using get or default because if A is not present in the map, then by default its frequency will be 0. And if it's present, then you will just get the frequency. And let's do the same thing for the B. So if the frequency is not matching, since we want the number with the greatest frequency to be appeared on top, so we'll do compare with frequency B, frequency A. So this will sort it in the descending order. And if the frequency is same, then we'll compare based on the elements itself. So the elements also you have to sort it in the descending order. So that's why we compare with B comma A. If you want in the ascending order, you will write integer dot compare A comma B. So the same thing, we also need to do it for this as well. So to prevent the duplication of the code, we can just create a comparator variable. So comparator to this thing, and we can just use this comparator here instead of defining it again and again for both of the tree sets. Okay. And we need a comma. So we have defined our both tree sets. The first thing is we'll iterate on the first window, which is the first key elements. So I equal to 0, I less than k. Map dot put sums of I, map dot get or default of I comma 0 plus 1. So we are just iterating on the first k elements and just increasing the frequency. And we are using the get or default method because the first time we add it, it will not be present in the map. So when it's not present, okay, this is round brackets. So when it's not present, the frequency by default will be 0, and to that 0 you are just adding a plus 1. So once this is done, you will need to iterate on all the keys and add all the keys in your bottom set. So iterate on all. So to iterate on the keys, we can use an iterator map dot key set. So you'll just add all the keys in your bottom tree set. I think X is already used. Let's use key. Also, we can see that whenever we add all these keys in our tree set, the addition happens based on the comparator we have custom declared. So it will first check the frequency, which is greater, and the frequency is same. It will compare based on the key. And once this is done, we need to find the answer for our first window. So to find the answer, like we have discussed, so initially what happened is, let's dry run along with the code. So we have added the first 6 elements, 1, 2, 3, 4, 5, 6 in our hash map. So hash map looks like this. 1 has frequency 2, 2 has frequency 2, 3 has a frequency 1, 4 has a frequency 1. So we'll just iterate on all, we just iterated on all these keys and added them to our bottom set. So 2 has the greatest frequency, so 2 will appear on the top, then 1, then 4, then 3. So this is our bottom tree set, and initially the top tree set is empty. So what we have to do is we have to transfer the elements from bottom to top. So to transfer the elements, let's say while top x set size is less than x. So while the size is less than x, we need to keep adding elements from the bottom one to the top one. But the bottom might not contain x elements, so we should also check the bottom set should not be empty. And the bottom is not empty. So let me just get the top element from the bottom set. Bottom dot whole first. So in this case, first this 2 is popped out. So once we have that, we will update our sum plus equal to num into map dot get num. So in this case, we had a sum 0. In our sum, we'll add a 4. 4 because 2 is present 2 times in our hash map. So 2 is popped and 2 is added in this. So we have to add this 2 in our tree set, in our what is this top x tree set. So this dot add num. So this is the process of transferring, and once this is done, we'll just set answer of 0 equal to sum. So the answer for the first window is calculated. Now we need to use this answer and iterate on the remaining array. So we have to slide the window basically. So let's define 2 variables for the window. L equal to, initially the first window was L equal to 0, R equal to k minus 1. And since the first window is already processed, we will start from the next window, which is from L equal to 1 and R equal to k. And we'll run the loop while R is less than n. So while the right side of the window will reach the last element. Okay. So we have to add nums of R. Nums of R will be added is the new element that is introduced, and nums of L minus 1 is the element that is getting deleted. So first step is we have to delete both of these numbers from the tree sets. So wherever they might be present. I think I need to update this as well. So 1 also gets popped. So in your sum, you will add 2. The total sum is 6, and 1 is getting added here. So when the first window is done, so this will be your configuration. In this, you will have 2 and 1. In the second tree set, you will have 4 and 3. So now what you'll do, you need to delete this nums of r. So wherever it might be present. So first let's check where it's present. If top x set dot contains nums of r, we'll just delete it. Dot remove nums of r. And note that whenever we delete or add something from our top set, we also need to update the sum accordingly. So from our sum, we'll subtract nums of r into the frequency. Else if it's present in the bottom set, just copy this. So else if it's present in the bottom set, we'll simply delete it from the bottom set. We don't need to update the sum because sum is only referring to the top set. So from bottom set, we'll remove this. So the same thing, same process we need to repeat for the nums of L minus 1. I think again here we have a duplication, so it's better to use a function for that. Let's say delete. So we need to pass both of these tree sets. Bottom set. And I think we also need to pass the hash map. What else we need? We need the sum. So let's pass the sum as well. And we also need the number that is getting deleted. Int num. So this is the function. Let me just copy paste this one here so that we can reuse it for both of the numbers. Okay. So instead of nums of r, I'll replace it with num. Yeah. So the entire thing we can just replace by delete. We need to pass the top set. We need to pass the bottom set, then map, then variable sum, and the element to delete, which is nums of r. So the same thing we'll repeat, but this time we'll delete nums of L minus 1. So we can delete this part. But note that we are passing the sum here, and whenever we update the sum, it won't get reflected here. So to get it reflected, we can have the return type of this as long. And whenever you update the sum, just return the sum. And when you call this, just store the variable sum equal to delete. Okay, so now the deletion is done. Now we need to update the frequency of these both elements in our hash map. So map dot put nums of r, map dot get nums of r plus 1. So you're just increasing the frequency of this nums of r. And again, this nums of r might be added for the first time. So you don't know, you don't want to for this value to go null. So this value will be null if it's not present for the first time. That's why we use get or default. Get or default nums of r comma 0 plus 1. So this is for the addition. The same thing, let's do it for the deletion for L minus 1. For L minus 1, we don't need to use get or default, because since you're removing the frequency, so that guarantees that the frequency is already present. So just get the frequency, and to that subtract a 1. Dot get L minus 1. And you'll check whether the frequency is 0. So if it's a 0, you can completely delete it from your hash map. So if map dot get nums of L minus 1 equal to 0, then map dot remove nums of L minus 1. So the frequency is updated. So after this, you will just add both of them back to your bottom, the bottom tree set. So bottom tree set dot add nums of r, and the same thing for nums of L minus 1. And like we discussed, when we delete this number, if it completely vanishes from the array, that means if the frequency is 0, then we should not add it in our bottom set. So let's first check whether map dot contains nums of L minus 1. So if it contains, then only we'll add it. And once this is done, we need to transfer the element from bottom to the top. So I think we have the transfer logic here. Just paste it. And this is also a duplicate code. So we'll quickly put this in a function. Long transfer. Let me copy these terms. So for transfer, what do we need? We need the top set, bottom set, we need the map, we need the sum. We don't need the number, but we need to pass the x. So where is the transfer logic? This one. We just paste it here. And at the end, we'll just return sum. So for transferring, yeah, while top is less than x and bottom is not empty, you will get the bottom. In your sum, you'll add the frequency. So the map is also present here. And then you'll return sum. So we can delete this and just write transfer. And in this, again, you'll pass all of these variables. The two tree sets, your hash map, your sum, and for this you'll pass the x. So you can simply use the function again. So now let's see what happens. The first window has the answer calculated, and now we are on the second window. So this is the second window. So first what happened is you deleted both these numbers. Sum equal to delete and delete. So the first time when you do the delete, you are trying to delete the number 2, and next you will delete this one. So when you delete the number 2, it gets removed from this, and it gets removed from the sum as well. So from 6, sum will be 2. And when you delete the 1 as well, 1 gets removed from here and sum will reach 0. Let me just write it properly. Yeah, so sum is 0 so far, and we have deleted both these numbers. After that, what you have done is we just updated the frequency of both the numbers. So 2 will get a frequency increment, and 1 will have a frequency decrement. So this will be 1. After that, what we have done, we have added nums of our inner bottom set. So the 2 will be added here. And map dot contains key nums of L minus 1. So yeah, 1 is present in this. We'll add the 1 as well. And this time 1 will be added at the bottom because its frequency is only 1. So this is the simulation so far. After that, we are doing a transfer. So in the transfer, what we are doing is, while the top size is less than x, we keep transferring the elements. So you'll transfer a 2 and you'll transfer a 4. And whenever you transfer these two elements, oh, I think this is a 4. Yeah, whenever you transfer the elements, you'll also update your sum. So 2 is present 3 times and 4 is present 1 time. So total sum will be 10. So the sum, you will store it in this variable because this transfer will return the sum. After doing all the transfer, it will return the updated sum. So once you have the updated sum, you can just store it in your answer of L equal to sum. I think we have also discussed the part where in this tree set, you might need to swap the element from this. So the best one in this and the worst one in this, you need to compare. So let's do it in the next iteration, because in this iteration, we don't need that. Because we can see that the best one in this is 3 and the worst one in this is 4. So if you compare both of them, so 4 only has a greater priority and 4 is present in this one only. So we don't need to swap. So we'll see it in the next iteration, what we have to do. So this is the iteration so far. Your bottom set is 3 and 1. Your top set is 2 and 3. Your sum is 10. So 10 is added to your answer. Finally, let's move to the next window, which is this. So in this, 3 is getting added and 1 is getting subtracted. So you entered the while loop. First, you have to delete both of these elements. So first you delete a 3. So where's it? You'll go to the delete function. It's not present in the top, so it's present in the bottom one. So from the bottom, you'll just remove the number. So 3 is just directly removed from this. And the same thing for 1 as well. 1 is present in the bottom, so you'll simply remove this. You won't update the sum. So far, both of them are removed from your bottom set. So after deletion, what we have done, we need to update the frequencies. So frequency of 3 will increase by 1 and frequency of 1 will become 0. And because frequency of the 1 became 0, you'll completely delete the key. So 1 is completely deleted. So once the frequencies are updated, you will add this 3 to your bottom set. So 3 gets added. You'll also try to add 1, but before that, you'll check whether 1 is present in the hash map. Since it's not present, you won't add this. So this is done. After this, you will do the transfer method. So transfer in the sense, you will transfer elements to the top tree set until its size reaches x. So in the transfer method, so the transfer won't happen because the top size is already equal to x. So transfer doesn't happen. So far, your sum is only 10. But in your answer, if you see, the sum is 12. So this is wrong. And also, if you see for the third subarray, the answer is based on yeah, the answer is based on 2s and 3s. But here you're getting the answer from 2 and 4. Also, if you validate, if you compare 3 and 4, 3 has a frequency 2 and 4 has a frequency 1. So 3 should be given more priority than this 4. So these both numbers should be swapped. So let's quickly do the swap and we will be done with the code. So first thing, to do the swap, we need to check if the bottom is not empty. So if bottom set, if bottom set is not empty, we'll get the best value from the bottom set. Bottom set dot first. So bottom set dot first will give us the top value in this bottom set. And also we need to get the worst value from the top set. Oh, where do we have? So to get the worst value, we'll do top set dot last. So in this example, your best will be 3, which is this, and your worst will be 4. So now you need to compare both of these values. So first you'll check if map.get best has a greater frequency than map.get worst. If the frequency of this 3 is greater than the frequency of 4, then we need to swap it. Also note that we need to swap if the frequency is same and the number is itself is greater. So suppose we have two numbers here. Let's say, suppose we have two numbers here and both frequency of both the numbers are same. But let's say we have 3 here and we have 4. And let's assume frequency of both of them are same. Since the frequency is same, we need to check the element. So 4 is greater than 3. So then also we need to do the swap. So let's add that condition also. If frequency is greater or frequency is same. Where is this ending? Frequency is same and best is greater than worst. I think I'm not missing any brackets. Yeah. So either of these both conditions are true, then we need to do the swapping. So to do the swapping, we'll remove the elements from the appropriate sets. So from the top set, you'll remove the last element. I mean, you'll remove the worst element. And same thing from the bottom set, you'll remove the best element. And once you have removed this, you'll add them in the reverse order. So in the top set, you'll add the best. And in the bottom set, you'll add the worst. Also, since you are removing from the top set, you need to update your frequency. So sum minus equal to worst into map get worst. And here you're adding an element to your top set. So you again need to add the sum, increase the sum. So sum plus equal to, you're adding best, right? So best into map.get best. So here we have done the swap, and at the end you'll just store whatever the sum you have in your answer. Then to move the window forward, L++ R++. So in this example, your sum was 10. So from the top set, you're deleting the 4. So sum will be 6. And in the top set, you're adding the 3. And 3 is present 2 times. So to this 6, total 6 gets added. So total you will have a 12. So answer for the last window is 12. And at the end of the while loop, we just return the answer. Just test it. Okay, we have few errors. At line 12, okay, this is num. What here? Here t should be in small. And then DEF AULT default. Okay. Let's see what's the issue. So when we do the transfer, we are not storing the answer in our sum. So when the transfer happens, our sum variable gets updated. So we need to catch that variable. So sum equal to transfer. Okay, now it works. Let me submit. I think there's a integer overflow happening. Like we can see that the numbers are up to 10 power 9. And in our code, we are multiplying the number with the frequency. So this term might overflow the integer range. So it is true that we are taking long variable for the sum, but when we multiply these two numbers, both these numbers are integers. So when you multiply two integer numbers, the multiplication happens in integer. And since it's happening in integer, the value will get overflowed. And that overflown value is getting stored in our sum. So to prevent that, we can typecast one of the number to long and then do the multiplication. So let me do the same thing wherever we are multiplying. I think here and here. I think now it should work. Okay, let me submit. Okay. I think there's some other error. I think the issue is here also we are doing the remove, but we need to add them back to our tree set. Let me submit again. Yeah, now it works. Finally, let's do the time and space complexity analysis. So this is where a function is starting. We are iterating on the first key elements, and after that we are just iterating on the keys. And we are doing a transfer. So this transfer will take at most x, order of x steps. We just write it. So far it's order of k. And here we have order of x. And this loop will run until in the worst case order of n. So let's have order of n here. And in this, we are doing delete operations, and we are also doing a transfer. So in both delete and transfer operations, the complexity for getting the element from the tree set or deleting it's log n. So in this while, the complexity of this while loop is total log n, and this while loop is running n times. So total complexity will be n into log n. So n log n plus order of k plus order of x. So comparing to this term, these both terms are not significant. So the total time complexity will be order of n log n. So we have is equal to order of n log n. And coming to this space complexity, it will be order of n, because we are creating a hash map which will store at max n elements, and same thing with the hash sets with the tree set. It will also it can also store at max n elements. So time complexity order of n log n and space is order of n. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. And let's catch up in the next video.